visual perception. In photography, parallax errors. Occur when the viewfinder and the lens do not share the same line of sight. This discrepancy can lead to misalignment between what the photographer sees and what the camera captures. Some cameras are designed to minimize parallax effects, especially in rangefinder and twin-lens reflex models. In human vision, parallax contributes to depth perception. The slight difference in the images received by the left and right eye, known as binocular parallax, allows the brain to construct a three-dimensional understanding of the environment. This ability is critical for everyday tasks such as reaching for objects, walking over uneven terrain, and navigating through space. Modern astronomical instruments utilize parallax in highly sophisticated ways. Space-based observatories, free from the distortions of the Earth's atmosphere, have measured stellar parallaxes with unprecedented precision. Satellites equipped with highly sensitive detectors can observe minute shifts in the positions of stars, enabling the creation of detailed three-dimensional maps of our galaxy. These advancements have allowed astronomers to study the structure and distribution of stars, identify clusters and associations, and refine models of galactic evolution. The ability to measure parallax at such small scales has revolutionized our understanding of the Milky Way and provided a foundation for exploring the universe beyond. Parallax also has applications in mapping and navigation on Earth. Surveyors have long relied on triangulation techniques based on parallax principles to measure distances and create accurate maps. By establishing a baseline between two observation points and measuring the angle to a distant object, surveyors can calculate its position with remarkable accuracy. This method has been essential for the development of cities, infrastructure, and transportation networks. In navigation, parallax measurements can assist in determining the location of ships and aircraft, enhancing safety and efficiency in travel. In the field of astrophysics, parallax is used in combination with other observational techniques to derive critical physical properties of stars. By measuring the apparent displacement of a star, astronomers can determine its distance and, when combined with brightness measurements, calculate its intrinsic luminosity. This information provides insight into the star's size, temperature, and stage in its life cycle. Understanding these properties is essential for constructing models of stellar evolution, studying the formation of galaxies, and predicting the future development of cosmic structures. The concept of parallax also extends into modern technological applications, including virtual reality and computer graphics. In virtual environments, simulated parallax provides users with a sense of depth and realism. By rendering objects differently based on the viewer's perspective, designers create immersive experiences that mimic real-world perception. Parallax effects are also used in video games, web design, and animation to enhance visual storytelling and engagement. These applications highlight the broad relevance of parallax beyond scientific measurement, demonstrating its role in shaping human interaction with both virtual and physical space. Historically, the study of parallax has been closely tied to the development of the scientific method. Early astronomers, including ancient Greeks and later European scholars, sought to understand the apparent motion of stars and planets through careful observation and measurement. The successful detection of stellar parallax provided empirical evidence supporting the heliocentric model of the solar system, challenging long-held geocentric beliefs. This achievement underscored the importance of measurement, observation, and mathematical reasoning in advancing scientific knowledge. Parallax thus serves not only as a practical tool, but also as a symbol of humanity's capacity to understand the universe through careful study. In contemporary research, parallax measurements contribute to the study of dark matter and dark energy. By determining precise distances to stars and galaxies, astronomers can map the distribution of visible matter. These investigations are critical for understanding the large-scale structure of the universe, the dynamics of galaxy formation, and the expansion of space itself. Parallax remains a cornerstone technique for probing the cosmos, providing essential data for theories about the composition, behavior, and ultimate fate of the universe. Parallax also intersects with the field of exoplanet research. By measuring the precise motion of stars over time, astronomers can detect the subtle gravitational influences of orbiting planets. This technique, known as astrometric parallax, complements other methods such as the transit and radial velocity techniques. Astrometric measurements allow scientists to determine the masses, distances, and orbits of exoplanets, contributing to our understanding of planetary formation and the potential for inhabitable worlds beyond our solar system. The integration of parallax into exoplanet studies exemplifies its continuing importance in cutting-edge astronomical research. The educational implications of parallax are significant as well. Teaching the principles of parallax helps students develop spatial reasoning, geometric understanding, and observational skills. Hands-on activities such as measuring the apparent shift of nearby objects from different vantage points provide intuitive experiences of distance, scale, and perspective. By engaging learners in both practical experience and theoretical exploration, educators can foster a deeper appreciation for the interplay between observation, measurement, and scientific reasoning. Parallax thus serves as both a tool for research and a gateway for cultivating curiosity and critical thinking. Positive psychology is a branch of psychology that focuses on the study of human strengths, well-being, and the factors that allow individuals and communities to thrive. The field emerged in response to the traditional emphasis in psychology and in psychology on mental illness and pathology, seeking instead to explore what makes life fulfilling and meaningful. The Positive Psychology Center is an initiative devoted to advancing research and understanding in this area, with a particular emphasis on evidence-based interventions and cultivation of personal strengths, and the promotion of flourishing at both individual and social levels. The work conducted at the center is organized around several core themes, including happiness, resilience, character strengths, engagement, relationships, meaning, and achievement. Researchers examine these areas to identify the underlying mechanisms that contribute to positive human experiences and to develop practical strategies for enhancing well-being. Studies conducted within the center often utilize the combination of longitudinal surveys, experimental interventions, and observational methods to capture a comprehensive picture of human flourishing. By employing rigorous scientific methods, the initiative seeks to provide reliable and actionable insights into the process that foster personal and communal growth. One of the primary research areas focuses on happiness and subjective well-being. Researchers investigate the factors that contribute to sustained feelings of satisfaction and contentment, exploring variables such as life circumstances, social connections, personality traits, and cognitive patterns.